All right, the last page of notes that we're going to be discussing is just some properties of vectors, addition, subtraction, how we can group these. And then we're going to talk about the standard basis vectors. So first things about is the property of vectors. And I want you to look at, one, what it means is that, vector addition is commutative. The order does not matter. We're still going to get the same vector whether we add a plus b or b plus a. 2 gives us grouping, so there's an associative property with vector addition. 3 is an additive identity. If we add 0, we're still going to get back that same initial vector. 4 is kind of the additive inverse. If we add the negative vector to the original vector, we're going to get the vector 0. 5 shows the distributive property with vectors, and if we with scalar multiplication. 6, again, it's the same as the distributive property with but with 2 scalars. So c plus d are scalars and a is our vector, and we can go ahead and distribute our vector into our scalars. 7 again is an associative property with scalar multiplication with our vectors, and then 8 is basically the identity, multiplicative identity, where we multiply it by a scalar of 1 and we get back that same vector. So now 3 vectors in our three-dimensional coordinate system, which we're going to label this V. So V sub 3 plays a special role, and we have the vector I, the vector j, and the vector k. And what this allows us to do is it allows us to write our vectors in sort of like an equation. And this is how a lot of vectors are represented in physics or engineering classes. So instead of writing a vector as let me make that a little bit smaller. So instead of writing our vectors like A, B, C, what the standard basis vectors allow us to do is write vectors as AI plus BJ plus CK, where those both represent the same vector. So we could say, okay, this was vector V, that's also vector V. All right. So because I, J, K have all length of 1, these are all going to represent directions in a certain axis. So I is going to represent the direction, the x-axis. J is going to represent the direction, the y-axis, and Z is going to and K is going to represent the direction in the z-axis. So here we have a little question. If A is a sub 1, a sub 2, a sub 3, if that vector A is represented by that, then we can write A as a sub 1 I plus a sub 2 j plus a sub 3 k. So why? So this is the reason why we're able to do that. Because our vector A is defined by a sub 1, a sub 2, a sub 3, what I can do is rewrite my A vector of a sub 1, a sub 2, and a sub 3, and I'm going to use some properties of vectors, and I'm going to say, well, to write out this vector, I could just say that it was a sub 1, 0, 0, plus 0, a sub 2, 0, plus 0, 0, a sub 3. And that is equivalent to A. And now, because I've changed the way that I've decided to represent vector A, I can also now determine, oh, hey, I can actually pull certain terms out of each of these vectors. And so this will give us I can pull out, if I pull out an a sub 1, I'm going to get vector 1, 0, 0. If I pull out, let me zoom in to give me some more room. If I pull out an a sub 2 in the second vector, I'm going to get 0, 1, 0. And if I pull out an a sub 3 in the last vector, I'm going to get 0, 0, 1. And based off of what we know as, the 1, 0, 0 vector, this allows us to write a sub 1 times I, because this whole value is I. Show you right here, back there. Alright? So then I can say a sub 1 I plus a sub 2, the 0, 1, 0 vector is just j, plus a sub 3, and the 0, 0, 1 vector is just k. And so that's why I'm able to rewrite vector A as, instead of a sub 1, a sub 2, a sub 3, as a sub 1 I plus a sub 2 j plus a sub 3 k. So basically all this is it's just another way to write a vector. But this is called, standard basis vectors. And again, this is used a lot in physics and engineering. So now, let's talk a little bit about the unit vector. So a unit vector is a vector whose length is 1. Hence the term unit. Alright, we're moving 1 unit. So for instance, I, j, and k are all unit vectors because they have a length of 1. In general, if our vector does not equal 0, then the unit vector that has the same direction as A can always be found. And so we'll say the unit vector, and we'll, denote a U there, boldface U, to denote that this is the unit vector. And how we can find the unit vector is basically by taking our vector and dividing by the distance of that vector. And so that should be intuitive. If I want to, get to 1 from 5, I'm just going to divide by 5. So if I want to get a vector back to 1, I'm just going to divide by the total length of that vector. And so that's what we have here. Alright, so again, this formula is a formula that's going to be used quite often in this class to get to the unit vector. And so you're just dividing by whatever the distance is, whatever the distance of that vector is. Alright, so find a unit vector that's the same direction as the given vector. So we want to stay in the same direction, we just want to find the unit vector. And so we're going to use our formula above. And I'm going to say, well, our u, I'm going to denote it with the arrow above, is equal to our vector negative 4, 2, 4 divided by the distance of negative 4, 2, 4. Right? And I'll go ahead and denote that just because this is notes. Negative 4, 2, 4. And so now to find that, I'm just going to do the square root and square each term. So negative 4 squared plus 2 squared plus 4 squared. And so then I have negative 4, 2, 4. And that's going to be divided by negative 4 squared, 16, 2 squared, 4, 4 squared, 16. So let's look at, I have 36. Take the square root of 36. And that's going to give me 6. So therefore, my unit vector is just negative 4 divided by 6, 2 divided by 6, and 4 divided by 6. And of course, we can reduce that to be negative 2/3, 1/3, and 2/3. and there is our unit vector, where it has the same direction as the original vector, but will have a length of 1. And of course, we can, do the math. If you want to check it, just find the distance of our solution and make sure that it equals 1. And you're going to find that it does. All right, that does it for the notes today. Again, if you have questions, go ahead and email me, or you can ask